Now we are going to learn about Faraday's laws of electrolysis. Faraday first law divides into two laws, first law, second law. Faraday first law. The mass of the substance liberated at an electrode during electrolysis directly proportional to the quantity of charge passed through the cell, that is M directly proportional to Q. We know that the charge is related to the current, that is I is equal to Q by T, that is Q is equal to I into T. Substitute in equation 1, that is M proportional to IT, that is taking the proportionality sign, M is equal to Z into IT, where Z is known as electrochemical equivalent of the substance. So if I is equal to, I means current, 1 ampere current is passed, T for 1 second, then M is equal to Z. So what is electrochemical equivalent? Electrochemical equivalent is defined as the amount of substance deposited or liberated at the electrode by a charge of 1 coulomb. Amount of substances deposited or liberated at the electrode by a charge of 1 coulomb. This is known as electrochemical equivalent. Now what is Faraday's second law? Now when the same quantity of charge passed through different electrolytes, for example nickel sulfate, this is copper sulfate, this is cobalt sulfate. When same quantity of charge passed through different electrolytes, the amount of substances liberated at the respective electrode directly proportional to the electrochemical equivalence. This is the Faraday's second law. First law means M proportional to Q. Second law, that is mass of nickel directly proportional to Z of nickel. Z means electrochemical equivalent of nickel, like this. Mass of copper directly proportional to electrochemical equivalent of copper. Mass of cobalt directly proportional to electrovalent of cobalt. Therefore, mass Ni by Zni is equal to mass copper by Z copper, mass cobalt by Z cobalt. This is the Faraday's second law.